Hello and welcome to the video. We will be showcasing our take on NYU's Visualization of Machine Learning course's default project, the Large Language Model, or LLM, project. Generating visualizations from natural language, or NL, text has been becoming a bigger field in the field of information visualization. With the release of ChatGPT and its zero-shot capability, it opens the door to have a generalized NL model that converts NL to code of any visualization. A key component of our application in comparison to other applications is we allow the user to adjust their visualizations on the fly by providing feedback in our UI, which gets sent to ChatGPT via our prompting schematic. For the architecture, we utilized a Python Flask application as our backend. We had one file that handled the application and the functions, and another file that we called Message Manager. The Message Manager class managed the user inputs and helped build context to supply to ChatGPT initially, as well as when additional feedback was provided to modify the visualization. Our front end was just a simple HTML page that utilized a few JavaScript scripts, namely Ajax, to accomplish asynchronous page updates. Upon loading the application, the user must input a few things prior to getting a visualization. Namely, their own API key for OpenAI must be provided. From there, if the user wishes to use a specific dataset, we recommend uploading their own CSV to the application, though we have had success with generating our own dummy datasets and asking ChatGPT to retrieve one from the internet. For the purpose of this demo, I will be using a dataset that has the information on Boston Marathon winners in the last 100 or so years. After I supply my CSV, a table is generated showing all the values within the table. The application loads 1,000 rows at a time, but all values can be seen as desired due to the table having functionality for pages. The user can choose a particular page to navigate to, or just click Next to load the next 1,000 values. As you can see, when I click Next, nothing happens, due to the fact that this dataset only contains about 100 rows. Each page is exactly 1,000 rows, so if there's not 1,000 rows within the dataset, page 2 would just be blank, and so on and so forth. Now that I have a dataset loaded against the application, I can go ahead and create a prompt. After I create my prompt, I submit it to the application, and it begins to run. To give a point of reference, the performance is similar to that of a Jupyter notebook. Naturally, the larger the dataset, the slower the performance. However, the application has been shown to be able to handle datasets of over 5 million rows with ease. After some time, the visualization is generated and displayed alongside the code that is used to create the visualization. If this is what the user desired, they can stop here and save the image and code. If they wish to have changes, they can reprompt the application to modify it. For example, I'm not really liking how a bar graph looks for this dataset, so I want to change it to a pie chart. As such, I request to change it to a pie chart. Upon becoming a pie chart, I notice some small values are clogging up the visualization. I can reprompt it once more to have all the values smaller than 3%, or any arbitrary number removed from the visualization to make it more clean. Perhaps I don't like the colors that are currently assigned to it. I could ask the application to assign a brand new set of colors to the visualization, and it can do so with ease. If I want to start over with a fresh visualization and dataset, the reset button enables the user to completely clear all data, including their dataset, prompt history, context, and others. From here, using the application is no different than what I previously showed. To give a brief example, I'm loading this yellow.csv dataset. After it loads, you'll see that the table now reflects this new data. If I were to request a visualization, it returns this. If I wanted to spend more time, I could tweak this visualization to better suit what I want. However, at this point it's redundant. To evaluate performance, we utilized NVBench. We ran some queries with NVBench to generate some visualizations, and afterwards, we tested those same queries with those same datasets within our own application. Here's an example of a visualization created within our application compared to what is created with NVBench. As you can see, they are very similar. Overall, our success rate sat at about an average of 60%. Depending on the chart type and the dataset, success clearly wavered. However, we were pretty satisfied with the overall results. To give a bit more insight, we noticed scatter plots and bar charts seem to work pretty well in comparison to NVBench with our application. Given more time, we would run more tests to evaluate it further, but we are satisfied with current results. We thank you for watching and hope you have a wonderful day.